In this video, we will first take a look at how to construct an ellipse using affine transformations. First, we have to define the major axis of the ellipse, axis A, which goes from the center to point A, and is also the radius of the circle Ka. Perpendicular to this axis lies the minor axis of the ellipse, axis B, and goes from the center to point B, and is also the radius of the circle Kb. On the bigger circle, we randomly choose a point P, and with the use of affine transformations, we will now try to find the image of this point that lies on the ellipse. Let's first take a look at the affine transformation of the point B. Let's suppose for now that the major axis of the ellipse is the axis of affinity. Point B on the bigger circle is then projected into point B on the smaller circle with the blue ray. Since all rays in affinity are parallel to each other, all other points from the bigger circle will be projected with rays parallel to this blue ray. That is also what happens to our point P, only at this time we don't know where on the ray its image will be. Now let's take a look at the affine transformation of the point A. And let's suppose that this time the minor axis of the ellipse is the axis of affinity. Point A on the smaller circle is then projected into point A on the bigger circle with the green ray. If we construct the radius of the bigger circle through point P, we get the green point P on the smaller circle. All other points on the smaller circle are projected with rays that are parallel to this green ray, and the same goes for our green point P. Where both rays from the point P intersect, that is where we get the red point P, and this one lies on the ellipse. Just to be sure that we got the correct point, we can check by constructing a tangent of the bigger circle in point P and then defining the projected image of this tangent that of course has to pass through the red point P. Let's suppose that the major axis of the ellipse is the axis of affinity. We first construct a tangent of the bigger circle in P, which is perpendicular to the OP radius. Now we need the point where the tangent intersects with the axis of affinity, which in this case is the major axis. Points that lie on the axis of affinity are projected into themselves, and there is no need to search for their images, so this is an easy way of getting new points to help us solve the problem. Now let's suppose that the minor axis of the ellipse is the axis of affinity. We go through the same steps again by constructing a tangent of the smaller circle in P and marking the point where this tangent intersects with the axis of affinity. In this case, that would be the minor axis. If we connect these two points with a line, we must get the tangent of the ellipse through the red P. And that is exactly what we get. All that is left for us to do now is mark the other 2 points of the ellipse. This gives us a total of 5 points, which is just enough to construct the ellipse. Now let's take a look at the animation. This animation shows the construction of the ellipse with the movement of the point P on the bigger circle. So no matter which point we choose in the beginning, we always get the same result.